In these notes, we're going to look at graphing piecewise functions. So piecewise functions are really just functions that are broken up into different sections. And each part of the function tells you what line or function to draw and in what region to draw it, which is usually indicated by values of x. And you'll see what this means in just a moment. So for the first example here, we're looking at f of x equals negative 1x minus 1 if x is less than 0, and 1/2 x plus 2 if x is greater than or equal to 0. So we're first looking at where this function splits up, and it splits up at 0 for x. So we have one function less than 0 and one function greater than 0. So I like to mark the change points. So this is where x is equal to 0. So on the left side of this line, where x is less than 0, we have the function negative 1x minus 1. And so we graph this just like a regular linear equation. Start at negative 1, and we're going to go down 1 over 1. But notice down 1 right 1 is greater than x, so we don't need these dots over here. We want to go the other direction, this way. Okay, now the important thing to notice also is that this is where x is less than 0, but not less than or equal to. So at 0, we want to make sure that we show that our function goes to that point, but doesn't include it. So I'm going to use an open circle there. So here is our function to the left of 0. I think I actually want to change the color here so we don't get it confused with our line. So I'll make that a black dotted line. Very important, the colors of the things. Okay, so next we have 1/2 x plus 2 if x is greater than or equal to 0. So this one's going to start at 2, and since it's or equal to 0, I'm going to go ahead and make that a filled in circle to show that our function includes x is equal to 0. And it goes from 1/2 x plus 2, so up 1 over 2 for 1/2 x, just like this, and draw the rest of it. Okay, so this is the graph of this piecewise function, and so you can see that to the left of 0 for x, we have the red half there, and greater than or equal to 0, we have the blue half. Okay, looking at example B, we have f of x equals negative 1/3 x plus 1 if x is less than 0, again, and negative 4x minus 1 if x is greater than or equal to 0. So again, I'm going to mark my change point. It's still x is equal to 0 here, just to help me remember. And then for red, I'll do the less than 0 part. So again, we have less than, so our intercept is going to be an open circle, so I know that I'm not including 0 in my solution. And I go down 1 over 3 or up 1 left 3 is what I'll end up doing here. Because I don't want to go on the right side of that line. So greater than or equal to 0, it's negative 4x minus 1. So I do start at negative 1 with a filled in circle. And I'm going to go down 4 over 1. Like so. Okay, so there's example B. So knowing how to graph a regular linear equation definitely comes in handy here. Example C, we have f of x equals 3 over 2x plus 5 if x is less than or equal to negative 4, and f of x equals x if x is greater than negative 4. So I'm going to go to negative 4 here for x for my change point. Okay, so I'll stick with red for the less than. If x is less than or equal to negative 4. So this time I'm going to fill in this dot. It starts at 5. Now, one thing to keep in mind is normally we go to the y-axis to start a function. So I'm going to do that right now. But I know I only want my function to show on the left side of that line. So I will, well, you'll see what happens. I'm only going to draw it. I'll erase what I draw to the right of it. So up 3 over 2, or down 3, left 2. I'm going to use a filled in circle here, like this. So I don't need these 2 points. I needed them to help me get my function drawn, but once I have it, I actually don't want to have my red function to the right of this dotted line, so I need to erase those points. Okay, now for the blue to the right of this line, it's just x. So that starts at the origin and goes up 1 over 1 with an open circle here because I am greater than -4 but not equal to. All right, so if your function, or if your change point here for your piecewise function isn't at the y-axis, isn't at x equals 0, you do need to use the y-axis to get your function drawn, but then erase the extra stuff you don't need. Okay, last example here, we have a 3-parter. So one change point is at -2 for x, and one is at 4. So we've got 3 sections of our graph, 3 pieces. Okay, so I'll use red for this first one. X is less than -2, and f of x equals 3 if x is less than -2. So remember, that's just a horizontal line. So we're going to have an open circle here and a horizontal line to the left. In the middle, f of x is equal to 1 if x is greater than or equal to -2 or less than 4. So I have a filled in circle here at -2 and an open circle here at 4, and x is between them. And then for the right side, the greater than or equal to 4, f of x is -8. So let's go down to -8. It's a filled in circle, shaded or drawn to the right like that. So all of these happen to be horizontal lines, but if one of them had been a regular mx plus b type equation, one of my sections would have been a diagonal line, but they were all horizontal here. So that is how you graph a piecewise function. Just make sure that you graph the individual functions correctly up to that change point where the function changes to the other one.